You will hear me in the videos referring to some of the software that I use. I use Sprocket as my main cam software. The Sprocket I got from a very nice piece of software. I kind of run it down a bit in my videos, but I don't mean to. It's called Gearotic. It covers sprockets, gears, escapements, clock wheels, all sorts of good stuff. It's by Art Vanity, I believe, and it's a very good piece of software. It's just that it's not quite as easy. Well, it's very easy to use, don't get me wrong. In fact, it's an extremely easy program to use, but it's I find it easier sometimes to use Sprocket, put it that way. However, the G-coder that was produced directly from Gearotic worked once I figured out where the 0 was and how to get to that 0 from my previous position in Sprocket. So once I got that, I was fine. Just in the videos also, I keep coming back to them. This is the original Sprocket. As you can see, it's quite a bit different to the one I'm making. The reason I was asked to remake it was this is obviously being a built-up job. You can see it's being welded on here, and to be quite honest, I don't think they've got it very concentric, and it's the chain slapping all over the place. It's bigger in diameter on the body than it needs to be, so I turned it this just as a kind of to play around with the lathe a little. You'll see that the teeth are thicker than the original. I've got to thin them down yet. This here is a magneto stator. I think that's what they call it. I've also got to make an external thread to go in here. You'll hear a reference to me. I crashed the machine as well. I've ground out that damage since, and it should accept the extractor once I make that. I'll cover that in a separate program. But here you see for the first time on my machine the Duality Lathe in action. It's taken me 3 days to actually get this far, in that I had problems with the machine accepting anything excepting a constant RPM feed rate. In other words, set the RPM and give it a feed rate of X inches per minute. That was the only way it would work. However, it's working, so hopefully over the next few days I'll get a bit of practice in and I'll start producing stuff with this. This is just a quick test of the Pathpilot Wizard to see how well it works, and it's going fine. That's great. With predictability, the camera battery ran flat on me before I got this first piece finished, but there you see the results. There's quite a lot of overhang, so I don't know if you can actually see it on. If I try and get in closer, I might be able to pick it up. But there is some slight chatter marks there. You can just make a chatter pattern. But that doesn't surprise me given the overhang, plus the tool wasn't the sharpest. In fact, it wasn't even a tool for aluminium, so I'm quite pleased. I programmed in for a 1/8 radius and it's finished that beautifully, so I couldn't ask for more really. Well, I could. The ability to turn a larger diameter and steel. I'm having nothing but problems with larger diameter. Look at the chatter marks on that. I'll get a way around it. But that was just a couple of experiments to try the Duality Lathe out, and I'm not disappointed. It'll come in really handy for some of the work that I'll be doing on it. Things like making small valves for internal combustion engines models. That'll be great for that sort of thing. Nice for profiling and quite easy to program, I would think. Anyway, I'll continue with more, and I'll post a little later when we get a bit more experience. Yeah, for anyone that's interested, the G-code that you get from Pathpilot for just taking a diameter down and maybe putting a radius in the at one end of it on a shoulder, say. This line here and this line here rather, sorry, G95 and G96 are the spindle feeds and speeds. Now this will not work for the Duality Lathe, so I have to change it to the following. And they see what I've changed it to. It's now changed to G94 with a speed of 200 RPM and G97 a feed rate of 2.5 inches per minute. And that should work. I've got one more to change, which is for the finished cut, so I'll do that before I start the machine. Right, now you'll have seen yesterday the really bad heavy chatter that I had. That led me to thinking, well, okay, well, after that last mishap, I've reset my distance length of cut. It's got about 0.1 of an inch to go before it goes on to apply the next cut. There we go, and it should go past the end of the work. That's just nice. There we are. So let's hope this works properly. It's prone to stalling out. It's a very big chunk of metal. It's quite hard, but the cutting tool's quite nice and sharp this time, so I'm hoping against the odds that this time I get better results with it. You can see it's cutting nicely, it doesn't sound strained, so hopefully it'll work right, but we'll see. If it stalls, the problem I've got, I haven't got the cable that attaches the e-stop from the lathe to the mill, so it doesn't talk to the mill very well, and it continues to put feed on, but for the purposes of just trying the machine out, I think we're okay. Obviously I couldn't leave it unattended, otherwise it could really smash things up. You'll notice I've got the tailstock on. I had to be very careful how I set the machine up. I've got the set G30 so that it just moves the tool to between the revolving centre and the point on the centre. Hopefully that'll be a safe distance. It's cutting quite nice. We'll just keep an eye on it, see how it goes. I'll put the occasional drop of WD-40 on just to help things up. Here you can see the piece of bar that I started with. It was 2.5 inches diameter, EN36. It's a fairly tough but not too bad a metal machine. Just a look at the progress on this magneto sprocket so far. This is the job in the Duality lathe. You can see I've had to put some extra light in here because it's quite dark under the ATC, but you can see the finish on here is really quite good given the size of the lathe and the size of the stock. This is these are some of the cuttings I got from facing the end of the bar off. You can see the light, very thin cuttings, but nice. And these are the cuttings that were produced for bringing that down from 2.5 inches diameter to 3/4 of an inch. You can see they're all very tightly packed, but again, very thin. Because I was only using about a 3/3 cut, it took a lot of passes to get it down to size, but I was well pleased with the results. It's the first time I've used the Duality lathe. One of the tools, well, the tool that I used for all of that work so far, apart from drilling a hole in the end, was this tool here. Let's see if I can focus on the end of it. There you go. You can see there's a huge amount of top rake on the tool, and quite a reasonable amount of end rake. You can't really see it in this. Let's see if I can focus on it there. It doesn't show up too well, but let's see. There you go. You get the idea. But I did this in order to reduce the cutting load on the motor, because for a start off, I haven't got an emergency stop rigged up yet. The cable was missing from my kit when I went to sort it all out, and it's on order from the States, so it'll be here next week. The last thing you want is the lathe to stop while the tool still advances, and I couldn't leave the machine unattended. In fact, I wouldn't leave it anyway, but I couldn't leave it unattended while I was cutting stuff in the lathe. There you get a better shot of that cutting tool. But that's the reason that I use this cutting. Well, I ground this tool specifically with plenty of top rake. It's high speed steel. Worked lovely, worked beautifully. The next phase is to run the code for making the taper on the shaft. I managed to borrow one of the Path Pilot, I think it was parallel turning programs or parallel boring programs, and changed it to suit myself, and I ran it without a tool in the cutter and it seemed to work okay. So we'll have a go now with the cutter in and we'll see what happens. That's the lathe switched on. What I'll do is I'll let it run for about 8 passes and then try the taper in just to make sure it's about right, and I'll rerun the program. Well, that's 8 passes run, so I'll go to the park position and we'll try in the taper. Well, there you can see after 10 passes, with another 2 to go and a finishing cut, it's looking pretty good. I'm well pleased with that. It's a nice finish. A lot of chatter initially, but I slowed down the revs and put a bit of coolant on and it's just right. It's holding that, it's not binding it or anything, but it's pretty good. I'm well pleased. It was actually holding it quite a bit with some strength. Time there's a bolt on there, you'll not know. So let's give it another run through the cycle. There's a lot of spring in the boring bar. You'll hear it take up. I should have started the lathe first there. I started in reverse for a while then. Let's go back to the safe position. Hit the G30. And that takes it away to there. And this time we shall start it the right way. That's better. If I hit the cycle start, it'll run through the whole thing again. But we'll go through it. A bit of lubricant on there. Pass number 7. Number 9 coming up next. You'll probably hear the tool rubbing. A little bit of chatter maybe. There you go. Very high pitch, not going to hurt anyway. Shows you how much spring there is in there. There's quite a lot of spring in that boring bar. And that's numbered. Now you can see it's cutting okay. Number 11. One of the problems with that cutting tool is there's not enough top rate on it. Not that it matters. And there we are, just about finished. And that's it. So we'll see what it looks like. Just switch off here and skip along to almost to the end stop. There we are, that's it at the stops. And take a close look inside, it's not a bad finish.